Here are your video instruction for lesson 8.1, and this is starting chapter 8. Chapter 8 is about exponents and exponential functions, and lesson 8.1 is about applying exponent properties involving products. And reminder, products means that you're going to be multiplying something because products are the answers to multiplication problems. For your notes today, please, if I write in black, copy it down. If I don't write it in black, you do not have to copy it down. First thing, let's take a look at an exponent problem, something like 3 to the 5th power. I hope you all remember that the 5 gets called the exponent. And I'd like to make sure and remind you, what do we call that 3? The 3 ends up getting called the base. We got an extra line here on the paper. Try to ignore that. So the first thing we want to look at is to teach you about the product of powers property. Okay, and to look at that, we're going to look at two exponent problems that actually have the same base, something like 2 to the 3rd power times 2 to the 2nd power. And we got a 2 there that did not write correctly, so I'm going to erase that quick. Let's go back. If we have 2 to the 3rd power times 2 to the 2nd power, there is an easy way for us to get an answer to that or simplify that math problem. And it really relates to making sure you understand that this 3 means you're going to have 2 times 2 times 2, or 3 2's multiplied together. And also understand that that 2 means you're going to have 2 times 2 multiplied together. And as a reminder, remember we are multiplying right here, so this is multiplication that's done there. The board's acting a little funny and I don't want to start over. So if you look at what you have there, what you really have is 2 times 2 times 2 times 2 times 2, which is really 2 to the 5th power. Now I would guess you probably can look back up at the original problem and see we don't have to write all that out really. We could just look at it and know that we have 2, and we could add the 3 and the 2 as far as the exponents together to get 2 to the 5th power. So you don't need to write all this out. We'll erase it. We'll get rid of it. That's it written out with numbers, and if you want to see it written out with variables, it would be to have something like a to the mth power times a to the nth power, and that would become a to the m plus n power. And that right there is what's known as the product of powers property. And if we looked at some examples to have you do, if you copy these down with me, you could pause the video and see if you get the same answers as what I do after I work through them. But we have 3 to the 3rd power times 3 to the 7th, 5 times 5 to the 9th power. Let's look at having negative 7 squared times negative 7. And then let's have x to the 2nd power times x to the 6th power times x. Okay, so answers to this anyway. This one should become 3 to the 10th power. The next one should become 5 to the 10th power. And you might be going, hey, where did you get the number to add to the 9? If there is no exponent written in, remember that means that's 5 to the 1st power times 5 to the 9th power, and you have a 1 plus a 9 there as far as what you should add together. And once again, we would have the same thing down here. That really counts as negative 7 to the 1st power, and this is counting as x to the 1st power. So if we write those in, this is going to become negative 7 to the 3rd power, and this is going to become x to the 9th power. Alright, then we'll head to a new slide here and talk to you about a couple other properties that you will be seeing. Power of a power property. And that would be if we had something like 2 to the 3rd power and we were going to take that entire exponent problem and raise it to the 2nd power. And there's kind of an easy way to get to the answer to this and to show you why it's going to work. Let's remember what does 2 to the third power mean if we were going to take it to the second power? It means we have two of those. 2 to the third power times 2 to the third power. And what does each of these actually mean? It means 2 times 2. I have my... Now I don't have my tools on over here to get a pen back. It means we have 2 times 2 times 2, and then we have another 2 times 2 times 2. And if we're multiplying these all together, you should notice we actually have 1, 2, 3, 4, 5, 6. We have 2 to the sixth power. And if you look back up here, I hope you end up seeing how could we get 2 to the sixth power from what we have up here. It's to take the 3 times the 2 and multiply those together, and you would get 2 to the sixth power and not have to do any of this as far as to write that out. What does that look like if we write it out with variables? It'd be something like a to the x power raised to the power of y would equal a to the x times the y power. So at this point, I would like you to think about what you're really going to have to do is just keep straight. When do you multiply powers together, and when do you add powers together? And let's put a box around this to show that that is the important thing we have there. And go through, do a couple of examples. If we had 4 to the second power raised to the 7th power, I hope you know that's going to become 4 to the 14th power. And if we look at doing one other one, let's do it with a variable. If we had n to the 3rd power raised to the 6th power, that's going to become n to the 18th power. Okay, let's take another slide and talk to you about a third power that's introduced in the book here. It's called the power of a product property. Power of a product property. And that will be if we have something like 2 times 3, and we were going to raise that to the 3rd power, that will actually turn into, and I know this is multiplication that we have in here, but the way the power will work is going to be a lot like what it would be if we were talking about the distributive property. The 2 and the 3 will both get raised to the 3rd power. So the results of doing this are going to be that we're going to get 2 to the 3rd power times 3 to the 3rd power. And our answers are fine to leave this way if the directions say write your answers as a power. If we write that property out in terms of a variable, it would be like having something like a times b raised to the m power is going to equal a to the m power b to the m power. And there is that property for you. And if we take a look at some examples that you would see using this, we would have something like 42 times 12 to the 2nd power, and that would equal something. You can write that out. And then let's say if we had 9 times m to the 3rd power times n, and all this gets raised to the 4th power, what will that equal? In the top one, we would have 42 squared times 12 squared. And in the bottom one now, we would have 9 to the 4th power. We would end up with m to the 12th power because 3 times 4 is 12. And in the last one, n right now is being raised to the 1st power. So we would have to be doing 4 times 1, and that would be n to the 4th power. And if your directions say write your answer using exponents, we would be done with this problem. But if the directions simply said to simplify, we would actually have to take 9 to the 4th power and get 6,561. And 9 to the 4th power is 6,561. And then we would have m to the 12th power n to the 4th power. Also in your book on page 491 is some explanation of order of magnitude. Your assignment that you get tomorrow will have something to do with that too, so keep that in mind. But there's the basis of what you need as far as for the assignment that you will have out of lesson 8.1.